Hey there, algebra class. In this lesson, I want to talk about how to solve equations that have variables on both sides. And you can see that here, objective, lesson 1.5. Pause, that's my phone ringing. Yeah, so anyway, solving equations with one variable, one x, one variable, that contain variables terms on both sides. So let's roll through this. So to solve an equation with variables on both sides, we're going to use inverse operations to collect. The idea is we're going to group things together. We're going to get all the variables on one side, all the x's on one side, and all the constants on the other side. Really, and that's about it. Now, just a little warning, a little reminder. I want you to stay positive throughout your lives and your mathematical careers, and of course, in this lesson here. Often you will have values, I shouldn't say values, you'll have variables that are positive or negative depending on how you move them. And I think it's a good idea to take the greater absolute value variable and leave it alone and move everything to that side. And I'll show you what I mean here when I do some examples. So if we want to solve this expression that says this equation, 7n minus 2 equals 5n plus 6, what I'm saying about the greater absolute value is 7n's are greater than 5n's. So what I want to do is move this 5n over with this 7n and get this negative 2 or minus 2 over with this 6. And you're probably looking at that like, well, that's not so bad. So let's do it. So let's subtract 5n from both sides. Again, that's subtraction property of equality, right? What we do to one side, we do to the other. And that leaves you with 2n minus 2 equals 6. And of course, now we're just going to add 2 to both sides. And you say, hey, 2n equals 8. Well, right, some number n times 2 equals 8. So the inverse of that is division. So divide by 2, right? We're going to divide both sides by 2. And lo and behold, n equals 4. So what I'd like you to do now is try this problem. Pause the video and come back. Okay, you're back. You've tried the problem. And it looks like, what did you do? That's right. You've got 4 b's on the left, 3 b's on the right. You moved the b's over, right? You subtracted 3 b's to both sides. Put that on the board. Right, you said, hey, let's subtract 3 b's from both. And now we're going to subtract 2, and b equals negative 2. Sorry about my keys clanking. The next thing we want to look at is when you have to simplify each side before solving it. So now you've got this like series of things going on. I'm going to step to the board, and I'm going to use my loud projection voice so you can hear me. When I want to solve this, let's clean things up first. Okay, so on the left side of my equation, I've got 4 minus 6a plus 4a. Well, 4 minus 6 and plus 4 is minus 2a. Looks like my board's just a little hair off. Equals, now I've got negative 1. Oh man, I've got minus 5 times the quantity 7 minus 2a. Oh, well that means I need to distribute this minus 5 here and here. Right? I've got parentheses. This is multiplication. It goes to both places. So I've got minus 5 times 7 is 35, and negative 5 times negative 2a is positive 10a. Okay, now let's see. I can simplify this some more. 4 minus 2a equals negative 1 minus 35 is negative 36 plus 10a. Ah! Now you're probably thinking, okay, Mr. Rising, I can handle it from here. You can see I've got 10 a's on this side. I've got negative 2 a's on that side. Well, let's just add 2 a's here, and we're going to add 2 a's here. Now, if that's a little confusing, let me just get this bar out of the way. I just wanted to show that I'm not dividing anything. No, I'm just adding 2 a's. So now I've got 4 equals negative 36. 10 plus 2 is 12 a's. And now I've got a 4 on the left equal to negative 36 plus 12a. Now, in order to get rid of, or I shouldn't say get rid of, but move this negative 36, I need to add 36 to both sides. And now 4 plus 36 is 40 equals 12a. And finally, to get a all by itself, a times 12 equals 40. Well, the opposite of a times 12 is a divided by 12. So if I divide both sides by 12, here like that, the 12s cancel out. So a equals 40 over 12. Now you may be thinking that's a really unattractive solution. It is. Let's reduce this a little bit to see if we can clean it up. Both 40 and 12 have what in common? You're saying, oh, of course, they both have a 4, right? 40 divided by 4 is 10, and 12 divided by 4 is 3. So that's our simplified solution. It's not really pretty, right? That's also 3 1/3, but it works, okay? Now, I'd like you to try this problem. Check it out. It's example 2b. Again, I'm sort of following along with your book, but go ahead, pause the video, try this one, and let's see what you get. All right, welcome back. By now, you should have said, hey, we first have to distribute this 2 to both the x and the positive 2. When we do that, we get 2x and we get a 4. Now, the next thing I need to do is simplify the left side of the equation, because I've got a 15 minus 9, and you're saying, oh, well, of course, that's just 6. Now you've got 3x plus 6 equals 2x plus 4. Now we're back in familiar land. Again, I'm going to move that 2x over and move. I'm not really moving it, but I'm subtracting 2x for both sides, and I'm maintaining equilibrium, right? What I do to one side, I do to the other side. And that simplifies down into x plus 6 equals 4. Subtract the 6 from both sides, right? And you get x equals negative 2. When we talk about identities, all right, this is a term, you should put this in your notes. An identity is an equation that is true for all values of that variable. An equation that is an identity has infinitely many solutions. So I'll show you here. Some equations are false, though. These equations have no solutions. So for example here, 3 equals 2 plus 1. That's true, right? That's an identity. 3 equals 3. When I'm looking at another one, with expressions, x equals x. That's true. If x is 1, right, 1 equals 1. If x is 2, 2 equals 2. That's an example of having infinitely many solutions. Whatever I plug in here, I also plug in here, and that's called an identity. So these first ones, right, are true. Are true. But when I look at this, 4 equals 2 plus 1, 4 does not equal 3. No way, this is false. And the same thing down here. X equals x plus 3. Well, wait a minute. That's not true. If I subtract an x for both sides to try to move it over, I get 0 equals 3. Well, that's not true. 0 does not equal 3. Of course, that is false. So when we talk about identities, we're talking about true statements where you have infinitely many solutions. So let's take a look at these. Identify whether they have infinitely many solutions or no solutions at all. All right, well, the same process is involved. So let's simplify things here. I've got a 10 and a 1, so I've got 11. Let me do it this way. Negative 5x plus 11 equals, I've got a 7x and a negative 12x, so that's also a negative 5x, and 11. Wait a minute. At this point, you can say, hey, Mr. Rising, negative 5x plus 11 equals negative 5x plus 11. Of course, if you want to take it one step further, move all the x's to one side. Let's add 5x to both sides. Right? The x's drop out, and 11 equals 11. Infinitely many solutions. What I'm saying is whatever x I plug in here, I plug the same quantity of x in here and here, and that equation will balance out. If you take a look at this next one here, solve this one, well, let's do the same process. 12x plus another x is 13x minus 3 equals, oh, I've got 5x and 8x. Okay, great. That's also 13x minus 4. And you're looking at these two thinking, no, that's just not right. You're right. If I want to collect all my x's on one side, all my variables on one side, I'm going to subtract 13x's from both sides. Well, now I've got negative 3 equals negative 4. And you're like, no, doesn't work. No solution. And when I'm saying no solution, there is no value of x. No x, right? No value of x that makes this equation work. That's what we're saying. No solution means there's no value of x that makes this equation work. I'm at 11 minutes right now, so I want you to go ahead and try this next problem. Pause the video. Tell me if it has a solution or not. All right, you've started to sort things out, and you said, hey, here we go. Let's group like terms, right? Combine like terms. So identify your like terms. We're going to start combining them, and you end up with 3y plus 7 equals 3y plus 10. Right now, you should be getting that feeling in your stomach saying this isn't going to go well. I subtract 3y from both sides, and 7, of course, does not equal 10. That's a false statement. So the equation 4y plus 7 minus y equals 10 plus 3y is false. There is no value of y that will make the equation true. There are no solutions. We're going to do this graphically at some point too, and it's actually pretty cool to see how it works both ways. Last problem I want to do in my remaining 3 minutes. John and Sarah are planting tulip bulbs. John has planted 60 bulbs and is planting at a rate of 4 bulbs per hour. Sarah has planted 96 bulbs and is planting at a rate of 32 bulbs per hour. In how many hours will John and Sarah have planted the same number of bulbs? Okay, so I'm not leaving until I answer this question, right? I'm going to highlight it real quick. You guys like the green, right? In how many hours will Sarah have planted the same number of bulbs? How many bulbs will that be? Of course, how many will that be? If you want to try this, go ahead and pause the video and try it, and then I will go ahead and do it as well. All right, you come back and try it. I've got exactly 2 minutes. Let's do it. John has planted 60 bulbs, right? John has planted 60 bulbs plus 44 per hour, right? Sarah, so this is John. Sarah has planted 96 bulbs and is doing 32 an hour. The question is, where are these two equations equal? So 60 plus 44, H equals 96 plus 32, H. All right, let's group, let's collect. Let's subtract the 32, H from this side and this side. All right, 44 minus 32 is 12H. And then I got a 60, and I got a 96. So now what I need to do is subtract my 60. I'm extending my page here. So now I've got 12H equals 36. Oh, you're getting that warm, fuzzy feeling. Divide both sides by 12. And you said, oh, Mr. Rising, in 3 hours, they will have planted the same amount. Now, I've got exactly 50 seconds. Here's the thing. If you plug in 3 here, and how many will that be? 3 times 44 is 132 plus 60, and that is 192. If you plug in 3 hours here, 32 times 3 is 96 plus the 96 you started with, and that is also, guess what, 192. So, how many bulbs will that be? 192. How many hours? 3. I hope this helps. Stay tuned for more exciting stuff.